Okay, so today I was going to do a couple more homework help problems for the most recent homework number 5 on torque and angular momentum in rotational units or rotational terms. So I looked up most missed or frequently missed questions on the homework, and I think there was 3, maybe 6, and 9. So I was going to start out with number 3 here. So in that question, you had a figure skater who started out spinning slowly or relatively slowly at 3.5 radians per second. So there she is, and she's got her arms extended. Okay, so she's got the largest radius possible, and she's going at 3.5 radians per second. Sometime later on, she drops her arms to her side, and because her radius drops, right? So here's our angular momentum formula. This is equal to angular momentum is equal to moment of inertia times angular velocity. Okay, and if we break this down even further, we have I is some kind of a fraction, right? Like 1/2 or something like that, mr squared times omega, right? So when you decrease the radius, everything else being the same, your omega has to go up because your angular momentum is conserved. Your initial and your final have to be the same because you have a spin axis here and it's the same spin axis there. So as long as you have the same spin axis, your angular momentum is conserved. Remember that one? So we have to have the same angular momentum here as here. Okay, so that's what I'm showing with this bottom formula. So what we need to figure out is it says we want to figure out, let me look that one up again. Sorry, I thought I had it all memorized, and then I come and there we go. Okay, so find the ratio of her moment of inertia from the first to the second. Okay, so what we need to know is this. It turns out we don't even actually care about this one so much, other than the fact that knowing that decreasing our radius has to increase our angular velocity. They're related, okay? So this is the formula right here that we're going to have to use. So this before has to be equal to this after, okay? So let's write that out. L initial, right? Angular momentum initial has to be I omega, and that has to be equal to the L final, which is still I omega. Now we have a new omega here from here, right? Because our radius decreased. Now, it doesn't tell us our radius here or here. It doesn't tell us either of those radiuses. Call it 1 or maybe I and then final there, right? It doesn't tell us that. It doesn't tell us our angular momentum. So how in the heck do we solve this problem? Well, we just needed a ratio. We need a ratio of I over I, right? And it said, I think, initial over final, right? So how in the heck do we find that ratio? Well, we can do that. And the way we do that is because this is our key to the puzzle. Initial is equal to final, right? So I'm going to take this formula, this business right here, I initial times omega initial is equal to I final omega final. So let me write this out. L initial is equal to L final, okay? Well, L initial is not L initial, it is I initial times omega initial is equal to I final omega final, okay? Because this, right, anytime you have an equal sign, you can substitute that in for the other thing, okay? So I want to find my ratio of i's. So how do I do that? Well, that means I have to have my i's on one side and I have to have my omegas on the other side. I have to have them separated out, okay? So if we do that, we'll end up with I initial over I final. I know this is getting a little bit crowded. I'll rewrite it up here in a second, okay? In fact, I'm just going to go do that now. So we have I, so from here, I go there, I initial over I final, because I'm dividing this one out, okay? And that means that I need to go over this way, okay? So I'll end up with omega final over omega initial. And that is how I will find this. And let me make sure I'm looking at the right way of looking at this. Find the moment of inertia in the first case to the second. So you just want a ratio of the two, for first to the second, okay? So that looks like I need to have, first to second, okay? So I do know these two numbers, so I can figure out this ratio. I can't exactly figure out the number on top or the number on bottom, but I can figure out the total value of it, okay? So omega final, so if I rewrite this, I initial over I final will give me, well, omega final was 7.5, and my I initial was 3.5. So that is basically your ratio right there. If you want to simplify it out, you can. Okay, so that's problem number 3.